you for this wonderful opportunity to present some of the research that we do in Aalborg University, Denmark. And I will start by just going briefly through some of my own background, because it gives some of the context of the research. I graduated as an architect way back in 1984, and from 1984 to 2008 I worked in an architectural office the last 10 years as a partner. And our office was part-wise specialized in hospital design, and this picture is from one of the last major projects I was involved in. But in 2007 to 2008, I was project manager for a new intensive care unit at another hospital. And in connection with that, which I will explain in a minute, I decided to change my career in 2008 and become employed at Aalborg University. And it was because, in connection with the intensive care unit, a research project emerged in cooperation with Aalborg University. In Danish it's called Helende Arkitektur. In English it means healing architecture. And it was basically a research report containing about 200 scientific articles about how hospital design might influence treatment, patient and staff safety, wayfinding in hospitals, and so on. And one of the articles which really caught my attention and became kind of a revelation to me, and maybe some of you know it, was this study by Professor Roger Ulrich, published in Science in 1984, where he had studied some patients who had undergone a gallbladder surgery. And they all was hospitalized in identical patient rooms, but some of them had the view to a brick wall and some of them to a small group of trees. And he found that those hospitalized in the tree group was hospitalized almost a day shorter than those who had the view to the brick wall. And also there was a difference in medication. So as an architect, this really came as a kind of revelation, and I thought, well, can architecture really be that powerful? And also I thought, oh my God, what have we done over the years, not knowing actually about this kind of effects. But I also realized that because the patient rooms were identical, there was no data about the architecture itself, about the design of the patient room. And also that there was no, because there was no physiological measure, there was no kind of data on which kind of physiological mechanisms that brought this effect about, although it was assumed that it has to do with stress and anxiety. So the next logical question, or next logical step to take, I think, was to ask the question, can the architecture itself influence the healing process by way of the stress system? And two things was required then. First, the architecture had to be viable, and second, there must be obtained physiological data. So we was looking for a kind of stress test that we could use, and we chose the so-called triosocial stress test, which is a test in psychosocial stress and probably the most used in laboratory experiments of this kind since the early 1990s. And there's the lab setup is that there's a preparation room and there's a test room, which you can see here. There's a participant and there's a committee of three authoritatively looking persons. And the protocol goes like this, that there's 5 minutes for baseline recording. Then the test person is taken in front of the committee and is presented to the assignments. One is to present himself for 5 minutes orally, and then he is told that he will be given a second assignment, but not what it is. Then he's going to the preparation room and has 5 minutes to prepare his oral presentation. and then he comes in front of the chromatine, presents himself for 5 minutes, and then he's given the second assignment, which probably is the hardest one. He has to count backwards from 1,687 in steps of 13 for 5 minutes. And this has shown to be consistently stressful for most people. And then he goes back to the preparation room and relax for 40 minutes while the stress reaction slowly dies down. Then there was the requirement that the architecture had to be viable. And then I found out that at the university in Lund in Sweden, they have transferred this test to a virtual environment, a so-called cave, in which some video projectors coordinated by a computer creates an illusion of a three-dimensional environment when you wear some special glasses and a head tracking system. So that meant that we could systematically make a variation in the architecture. Then there was a requirement that we had to obtain physiological data, and we decided on to measure the two major stress systems. We made a heart rate variability measure to track the reaction of the sympathetic and parasympathetic nervous system, and we make saliva samples to measure cortisol, which of course maybe was the most interesting, because cortisol of course also is an immune regulating hormone. And this is the setup we made. We made the assumption that because stress is very much, often thought of as a preparation to a fight or flight behavior, we made a closed room, and we made a room with an opening, potentially allowing for an escape. So it's a room with, if you can see in the picture, it's a room with 3 large openings where the floor continues uninterrupted to the horizon. And this is our data. The solid curve is those from the closed room, and the dotted curve is those from the open room. And here's heart rate, here's sympathetic nervous system, and here's the parasympathetic nervous system. And here is the cortisol. As you can see, no part of the autonomous nervous system reacted significantly to the spatial context. But the reaction of the HPA axis, meaning the cortisol, had a less pronounced stress reaction in the room with the openings. As no part of the autonomous nervous system reacted, we concluded that it could not be related to the fight or flight reaction, as this is so closely tied to the autonomous nervous system. And just as a hypothesis, we have thought that it could be that the brain structure called the hippocampus could be the explanation, because the hippocampus has a very large number of cortisol receptors and is a direct part of the HPA axis feedback mechanism. And the hippocampus creates a cognitive map all the time, and is as a part of this all the time mapping the space boundaries. Also, you can see this line is where the test was performed, and you can see that the very big difference in the cortisol is actually after the test has been performed, when the participant have returned to the preparation room and is relaxing. And also it coincides with when, as you say, the sympathetic nervous system curve should be read that when the curves go down, the activity in the sympathetic nervous system goes up. So you can see that the big reaction in the cortisol only becomes visible when the sympathetic nervous system reaction has terminated. And it is kind of like that the sympathetic nervous system tries to counterbalance the HPA axis while both are in activity. So if this could be related to actual hospital design, you can say that if you have a room for example, treatment or examination, which can be stressful to the patients, then you will probably not have the big difference in the room itself, even if it has possibilities for escape. But a room with this kind of feeling of potential possibility for escape might result in a lower cortisol level after the treatment, which is perhaps also the most interesting, because that is where recovery and healing should take place. So I would say thank you for your attention.
Thank you, Lars. I think in our new clinic, all the patients' rooms will be with garden view.
Excuse me?
With garden view.
Yeah.
Are there any questions for Lars? I find this so interesting, even like I think in my own country we're starting to develop more long-term care facilities and making those rooms and environments more appropriate for those clients.
Yeah.
So it's very interesting.
Yes, thank you.
Thank you.